Hi, welcome to my video on graph the inverse of a function from a graph. So what I have here is a graph already done, and I have, this is not an inverse, I'm just doing the reflection in the y-axis. So this is the point, use a pen here, this is the point negative 3, 1. X is negative 3, y is 1. And I'm reflecting it, this point, in the y-axis. And so when I reflect it, I get 3, 1. So to show you that, I'm going to take the graph and I'm going to reflect it in the y-axis. So that turns it over like this, and I reflect it. And when I do, lodge it down, and I have, I reflect it in the y-axis, I have, this is showing you the reflection. This is negative 3, 1 becomes 3, 1. And when you reflect in the y-axis, x comma y becomes negative x comma y. So when you reflect in the y-axis, you get the x coordinate the opposite of each other, but the y doesn't change. Now, let's take the same point. Let's take the same point, and I have another one done. I have several done, more than one. So we take the same point, negative 3, 1, and reflect it in the x-axis. Then reflect it in the x-axis, I get the same x coordinate of negative 3, but the y changes from a 1 to a negative 1. And you might say, well, I understand that. So I'm going to reflect it in the x-axis. I'm going to turn it over this way and put it turned around. I'm reflected in the x. So this is what I have. It's the same point, but I'm just showing you that a negative 3, 1 becomes negative 3, negative 1. Reflected it in the x-axis, the point x comma y becomes x negative y. So the x doesn't change, but the y changes. So that's reflecting it in the x-axis. But now I'm going to do examples of reflecting in the line. So let's look at the same point again. So now I have the point x is negative 3, 1, and I'm reflecting it in the line y equals x. This line right here is y equals x. So that means when you reflect in this line y equals x, that means the x becomes y and the y becomes the x. So I'm going to take this sheet of paper and I'm going to hold on to the corners and I'm going to reflect it in this diagonal. So notice I keep my hands right where they are. So I'm reflecting it in the line y equals x. So when I take the point negative 3, 1, which was right here, it becomes 1, negative 3. So the x becomes y and the y becomes the x. So this is reflecting in the line y equals x. And again, x equals y and y equals x. Okay, let's take another example. This time, I'm taking the relation. I have this relation going from negative 2, 4 down to 0, 2, over to 4, 2, down to 7, 1. So I'm going to reflect this in the line y equals x. And reflecting that line, again, I'm not going to reflect it into y or the x. I'm turning it, I'm flipping the paper, the graph as on the diagonal. So another way to do this, watch, is to leave that where it is like that. Grab this corner and bring this corner down here and hold on like that and let the bottom one flip out. Oops, here it is. And you can see it's reflected in the line y equals x. So, and this reflection again of the inverse in the line y equals x gives you, again, before we had negative 2, 4, now we got 4, negative 2. Before I had 0, 2, now I got 2, 0. Before I had 4, 2, I got 2, 4. Before I had 7, 1, Now I got 1, 7. So there's this reflection in the line y equals x, which is x comma y becomes y comma x. And let's do another one. Okay, here we go. And I made up all these graphs. Now, here, I have a horizontal line that y equals 4. So that means every point on this line, horizontal line, the y coordinate is 4, and the x keeps changing. So when you do this reflection, again in the line y equals x, we'll flip it over. In the y equals x, here I go. I'm flipping it over, notching it down. There it is. And so y equals x, the y changes to an x. So instead of a horizontal line, we have a vertical line, which is x equals 4. Again, reflecting in the line y equals x. So a horizontal line becomes a vertical line because we switch the y and the x. Okay, another example is, let's take a parabola. And this is a parabola that has, as you can see, the vertex is 0, negative 3, and we have x is 1, negative 2, x is negative 1, negative 2, and so on. So you see all these points. So when you reflect that, watch what happens when you reflect the parabola, because we have two parts. So I'm going to reflect in the line y equals x. So that means x becomes y and y becomes x. So this 0, negative 3 becomes negative 3, 0. This 1, negative 2 becomes negative 2, 1. This one becomes negative 2, negative 1. And this one becomes 1, 2. And this one becomes 1, negative 2. And we also have two more points here. That's on the parabola. So let's reflect it. So we're reflected in the line y equals x. So we just turn it over like this. And there it is, reflected. And again, notice it's gone sideways. So it's reflected in the line y equals x. So before it was 0, 3, 0, negative 3. Now it's negative 3, 0. And this was 1, negative 2. Now it's negative 2, 1. This was negative 1, negative 2. Now it's negative 2, 1. So all the coordinates are switched, the x and the y coordinates. So just look at that one again. Let's reflect it back. There it is. So again, notice the vertex is 0, negative 3. And so, and we got 1, negative 2, and negative 1, negative 2. Just look at those points, reflect it back. And there it is, reflected in the line y equals x. So you can see the vertex and these 2 points. We have a parabola. That's this parabola. The previous parabola, initial parabola, is y in terms of x. This one is x in terms of y. So let's look at another example. The more examples you look at, hopefully the better you will understand. Or you might say, I understand what's happening now. So now I have, look, notice this is half of a parabola, if you think about it, because the other half will be coming down right here like this. So this is the parabola turned over, upside down. This is the maximum point. So this piece of the graph right here is, this is the vertex of 0, 2, and this is negative 1, 1. This is, point is negative 2, negative 2. And this one is negative 3, negative 7. So when I reflect this graph, which is half of a parabola, I'm going to reflect it in the line. Oops, let me write down. This is the line y equals x. That's where we're reflecting it. So when I reflect it, notice I have 0, 2. I have 2, 0. Notice the x is going to the left and the y is going down. So let's reflect it. Reflect it over. And so now we have 2, 0, x is 2, 0, x is 1, y is negative 1, x is negative 2, y is negative 2, x is negative 7, y is negative 3. So in the one on the other side, before reflected, we have 0, 2, we had negative 1, 1, we had negative 2, negative 2, we had negative 3, negative 7. And I just want to look at that a little bit closer. Let's look at the original. Notice here that x is starting at, the x value is starting at 0, and the x is going less than equal to. Starting at 0, x is going to the left, less than equal to. And the y, which is the range, the y is going down. The y values are going down. So the y values are starting at 2 and they're going less than equal to. So that means in the inverse, the x's and the y's are flipped around. That means that in the inverse, I should have x is less than or equal to 2 and y is less than or equal to 0. Let's see if that's true. So I'm going to reflect it. There it is. And we have the x values are x is less than or equal to 2. X starts at 2 and goes to the left. And the y values are starting at 0 and they're less than or equal to 0. So the x values are going to the left and the y values are going down. And again, that's switched. Let's look at it again. So x is 2, y is 0. So when I go back and I look at, I should have x is 0 and y is 2. So they're switched around. Okay, and let's try one more. And we have this one. I made this one up. Notice right now we have, this is what we call an exponential, and the base is 2. So actually the equation is y equals 2 to the x, but not really concerned, but you can see the powers is 2 to the 1, 2 squared, 2 cubed. So if you let x be 3, you get an 8. You let x be 2, you get 4. Let x be 1, you get a 2. Let x be 0, and you'll get a 1, and so on. X is a negative 1, we get a half. X is negative 2, we get a quarter. So this is an exponential curve function, and the asymptote is y equals, asymptote is horizontal, so the asymptote is y equals 0. That means, if you think about it, the asymptote on its inverse is going to be x equals 0. And these ordered pairs are going to be 8, 3, 8, 3, 4, 2, 2, 1, 1, 0, a half, negative 1, and a quarter, negative 2. So let's reflect it over, turn it over. And the line, what line? Reflected in the line y equals x. And when I flip it over in that reflection like this, there it is. I reflected it. So notice that my asymptote is vertical, x equals 0. On the other side, the asymptote was y equals 0. Now it's flipped, so it's x equals 0. And notice that this is y. Oh, let me write it in red because it's y equals log base 2 of x. So the inverse, I did a whole unit on exponential inverses and log inverses. So the inverse of an exponential is a log. So this is a log equation, and the asymptote is x equals 0. So that means the range is all values of x. So the domain is all values of x greater than 0, and the range is all reals. But you can see that if you take x's 8, 2 to the what power gives you 8? It's a 3. Right here we got x is 4. What power of 2 gives you 4? And the answer is 2. So the x and the y values are switched, interchanged. So we have an exponential graph that's on the other side becomes the inverse is a log graph. So I wanted to take my time and explain all that to you, and I did it. I could have done it without setting up those grids, but it's nice to see when you reflect like I was doing and showing you the X and the Y coordinates are switched to Y and X. So X comma Y becomes Y comma X when you reflect in the Y equals X axis. And that brings us to the end of the video. And if you like my video, click on the like button. If you're not a subscriber, you want to subscribe, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And the content is on my YouTube channel called Math Fully Explained, all one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.